Hello, my name is Greg Rice, Product Marketing Manager at ONSemiconductor. Today we'll be covering an overview of a data center environmental monitoring solution and how you can reduce energy costs through enhanced temperature monitoring. As the IoT continues to grow and more data is sent to the cloud on a continual basis, the amount of computing power in data centers will also grow. As more computing power is installed, the cost of cooling equipment becomes a significant portion of the total operating cost for data centers. Additionally, data center managers spend a significant amount of time working to identify the physical location of assets in server racks. To mitigate these issues, one solution is to use wireless passive sensors to monitor the air temperature inside server racks. Having a detailed heat map enables data center managers to adjust the amount of cooling in the data center based on the demand to improve energy efficiency. In addition to providing temperature data, each SPS sensor includes a unique ID that can be correlated to a specific server rack, enabling data center managers to easily identify the physical location of assets. To summarize, the benefits of using the SPS solution include optimized cooling, which translates to energy savings, early detection of failures leading to less equipment downtime, and the added benefit of physical asset tracking, which leads to lower labor cost as well as improved management of hardware resources. Moving ahead, we'll review the SPS solution for data centers in more detail. The SPS data center system solution is comprised of three primary components: the passive temperature sensors, the SPS reader hub, and RF antennas for the sensor hub. The battery-free wireless sensors can be installed inside server racks at desired locations, and their small form factor enables them to be placed directly onto rack equipment such as blade servers and hard drives. The sensor hub can monitor hundreds of sensors simultaneously, and each sensor is uniquely identified by the system, which is necessary for asset tracking applications. Additionally, the RF reader antenna is optimized for performance within server racks and includes options for adhesive or through-hole mounting. The SPS reader hub includes an API for software engineers to develop their own applications and can be connected through a standard Ethernet interface. This system kit is available for purchase and includes the complete hardware and software components shown here. The SPS system is easy to install and can be scaled across large data centers. The multi-port reader can be used to monitor multiple server cabinets, and one reader can typically read up to 8 server racks at a time. The temperature of components is continually monitored, and automatic alerts can be triggered if temperature trends outside of the normal operating range. This diagram shows the key blocks included in a typical electronic sensor. At the heart of every sensor is a sensing element, which is something that converts a physical parameter such as temperature or moisture into an electrical signal. All electronics require some sort of power, which is typically provided through either wired power or battery power. Also, there's typically some circuitry for data processing and connectivity, which could include microcontrollers, clocks, logic, and other components. Including all of these blocks in a single sensor imposes restrictions in the form factor and cost for each sensor due to the physical number of components required. For many applications, a traditional electronic sensor works very well. However, the size and cost to scale of traditional sensors has limited the deployment of sensor networks in some applications. Smart passive sensors, or SPS, take a different approach to implementing electronic sensors. The SPS system utilizes shared blocks for power, data processing, and connectivity, and individual sensor nodes that are designed using a single IC attached to a printed antenna. Smart passive sensors are powered by harvesting RF energy provided by a shared SPS reader hub and do not require any wired power or battery power. This enables the use of low-cost, small form factor sensor nodes that enable the deployment of sensor networks in applications where it is not feasible to deploy traditional sensors. SPS sensors provide data to indicate temperature, moisture, receive signal strength, and other parameters to the central reader hub. On this slide, you'll see a list of available sensors through ONSemiconductor, as well as their function, the UHF band, attached material, description of the package, as well as an image of the sensor. Current sensors provide the ability to sense temperature, moisture, and fluid level. The temperature sensors operate up to 85 degrees C with an accuracy of approximately plus or minus 1 degree C. Moisture sensors are designed to detect water leaks and provide a binary wet-dry indication. Fluid level sensors are designed to indicate if the fluid inside a non-metallic container is above or below a specific threshold. The sensors are divided into different operating frequency bands depending on the region where the sensors will be deployed, and are available in form factors that support placement on metal and non-metallic surfaces. Additional sensor designs are currently in development and will be available as they are released. Thank you for joining us on this webcast. For more information regarding the data center environmental monitoring system or our smart passive sensor solutions, please visit us at www.onsemi.com.